So the first thing I want to talk about is a little bit more about slopes. You know, we spoke a lot about slopes on Wednesday. We computed a few. And I'd like to point out a few things that you can do with slopes and some of the meaning behind what these numbers are. So I drew a little graph, and there's two lines, and those lines are parallel. Okay, so if you look at the slope of the two, they both go up 3 and over 4. You can see in the green notation that I have here, the slopes are the same. So the equation to these lines, the top one is going to be y equals 3/4 x plus 1. The bottom one is 3/4 x minus 1. So you can see that they have the same slope. Remember the form that we had of the line where y equals mx plus b. The m is the slope. You can see it has a different intercept. The top line intercepts at 1, and you can see that from the equation. And then the bottom one intercepts at -1, and you can see that from the equation as well. Okay, so these are parallel lines. And so what does it mean to be parallel? Okay, let's say, well, parallel means that they're not going to intersect, that these two lines have the same slope, so whatever change is going to happen to the top one, the same change is going to happen to the bottom one. It's going to neither get closer nor further away from the other line. If they did intersect, you would expect that the x's would be the same and the y's would be the same. So if you gave it an x, that you'd get the same y's out of this if those two lines intersected. Okay, so if we said, all right, the first line has that equation, second line has the 3/4 x2 minus 1. If we set the two equal to each other, you see there's no solution to this, right? If we subtract 3/4 x from both sides, we get plus 1 equals -1. And so we get a contradiction here that says that it couldn't be, that if we have two lines with the same slope, they're never going to intersect. And indeed, that's what parallel means, is that they're never going to intersect. And so here's our first fact, that parallel lines don't intersect. And the slopes of any lines that are parallel are the same. So if you look at any equation of the line that's in that form of y equals mx plus b, compare the m's, and if they're the same, they're parallel. Or if you want to set up a line based on a line that you already have and you want to make it parallel, then you choose that m from that equation. All right, so if we look at another thing about slopes, let me take a rectangle. And this rectangle will be 6 wide and 3 high. And I'm going to make a diagonal cut through this rectangle. And I'm going to rotate up that one side so it's on the end. So on one side we have this rectangle that's 3 high, 6 wide. On the other side we have one that's 3 wide and 6 high. So what I've done is I've taken that 90-degree angle and I've opened it up to be 180 degrees, right? 180 degrees is a straight line. And so what I've done is I've added a 90-degree angle between those two lines. That if I think of this as a piece of paper, that's the line that I cut along to open this thing up. So let's look at the slope. Okay, if we look at the slope of that diagonal line, we get the rise over the run. And now this line is going down, right? As we go from left to right, the line is pointing down, so we're decreasing 3 for every increase in the x direction of 6. All right, so we have the slope is -3 over 6, or it's going to be -1/2. Now let's look at the other slope. Okay, so let's look at that one that's on the triangle on the right. That one's rising 6 and running 3, right? And it's going from the lower left to the upper right, so we know it's positive. So the rise over run is going to be 6 over 3, and the slope is 2 over 1. Now I could have simplified that to just 2, but to illustrate my point, I want to simplify this to just 2 over 1. If you compare the two slopes, one is the negative reciprocal of the other. So in other words, you set up the fraction, you flip it over, and you put a negative sign in front of it, or if it already has a negative sign, then you make it positive. And so this is the characteristic of a perpendicular line. That a perpendicular line, these are lines that have this angle of 90 degrees between them, that the slopes of one line is the negative reciprocal of the other. Okay, so we take, like if we knew the line on the right-hand triangle, or the left-hand triangle is negative 1/2, you change the negative to positive, you turn over the fraction and you get positive 2/1, and that's the slope of the perpendicular line. And vice versa, it also works if we take the reciprocal of 2/1 and make it negative, we get negative 1/2. Yes?
So like if we get a problem like that, do we have to reduce it, or do you want us to leave it like that to do the rise over run, or do we?
I think reducing these kinds of fractions is pretty important. You know, I'm not going to give you horrendous numbers, you know, and reducing a fraction is basically factoring it and canceling out common factors. So I think in an ordinary sense, when we're making an equation of a line, if I were to make an equation of the line that has a slope of 2/1, I'd even simplify it further to be 2 as the slope. Okay? But just recognize that anytime you have an integer coefficient, that it's also a ratio of whatever that integer is over 1. So that will help you, you know, in terms of taking the negative reciprocal. Okay? We're going to have some practice at doing that. Now this is just a diagram to justify this slope is the negative reciprocal of the other slope. You just have to remember what's in the purple cloud there, that if we want to find the slope of a line perpendicular to another, we choose the slope and we take the negative reciprocal. Now the other thing that I want you to do is think of the slope as a rate of change. Okay, so if we take our definition of the slope, and let's say, you know, the y2 minus y1 over x2 minus x1 is a over b, think of this as for every increase in b units, there's an increase of a units. This is kind of saying the rise over run thing. So for every amount that you run, you're going to rise a certain amount. So the way this translates into, or you can apply this to a model, is that it tells you how fast something is changing with respect to something else. And I realize that is kind of abstract, so let me give a little bit more concrete example here. So let's say I'm riding my bike. At 1 p.m. I'm 12 miles from my home, and at 4 p.m. I'm 36 miles from my home. Okay, so here is a time and a distance. So my distance is changing with time. So I can take these two facts and make 2 data points. One is that at hour 1, I'm at 12 miles. At hour 4, I'm at 36 miles. And so if I calculate the slope, I get 36 minus 12 is 24, 4 minus 1 is 3, and I have 24 divided by 3 equals 8, so I'm traveling 8 miles an hour. So that's what the slope means in this context, is that it is the rate of change of my position. All right, and you're used to saying miles per hour is kind of like one word, and even the abbreviation is mph. But think of the rate as this is how much my distance is going to change for every increment of time that I'm changing. So every hour I expect to change for 8 miles. And so the nice part about linear equations is that the rate doesn't change in them, and so you can use this as a predictive kind of thing, or you can perhaps tell where you were somewhere in the middle. So, for example, at 2 o'clock, I would expect to be at 12 plus 8 miles, or 20 miles, and at 3 o'clock, I would expect to be at 8 more than 20, which is 28, and then 8 more than 28, I'm at 36. So I'm going 8 miles per hour, and so this is really the essential part of understanding the units of a slope as a rate of change. Okay, so let's look at how we establish the equation of a line given a couple points. Okay, we already know how to calculate the slope. what do we do to get the rest of the equation? And so we're going to use this fact about the slope, that it's constant for a line. It doesn't change. And when we look at its definition, we can choose any 2 points on that line and come up with the same slope. Just whatever's convenient. I can choose point 1 and point 2, and I get x1, y1, and x2, y2. And this stays constant no matter where I change. So if I make this even a little bit more general, now notice the difference in the first factor. I have y with no subscript minus y1 over x with no subscript minus x1. So that means for any xy on that line, this relationship holds. Okay? So I don't have to tell it an xy. What I can use this for is if I multiply both sides of this equation by x minus x1, I get this. And so this is my equation. Notice I have two variables, x and y. x1, y1 is the point that I have, and m is the thing that I calculated from point 1 and 2. All right, so let me give you a couple examples on this. So I want to find the equation of the line through 1, 2 and 2, 5. All right, so I have 2 points. First thing I do is I'm going to calculate the slope. So 5 minus 2, that's the change in the y values, is 3. The change in the x values is 2 minus 1 is 1. And so my slope is 3. And then I'm going to put it in that formula right here, this one, and say, okay, I know my m is 3, and I'm going to choose a point. And in this one, I'm going to use x equals 1, y equals 2, and I'm going to substitute for those two values in there, and then I get this equation. And then if I manipulate it, simplify it, okay, by first multiplying through to eliminate the parentheses, 3 times x and 3 times negative 1 gives me 3x minus 3, and then add 2 to both sides, I get this equation, y equals 3x minus 1. And so there's my equation. I got 2 lines, calculate the slope, and then I stick it into that formula. Okay, I'm going to go over another example almost exactly like it, but let me let you catch up on your notes. Okay, so what we call this form of the equation is the point-slope form. And so there's 2 essential pieces to it. Number 1 is the slope, that's m. And number 2 is this equation where you take the y minus y1 and m times the difference between x and x1. And these parentheses around this expression are vital, because once we start to simplify, we're going to distribute that m to the negative x1. Okay, so you don't just make it mx minus x1, you know, where you don't have any parentheses. Make sure the parentheses are in place, and then you can calculate what that line is. Yes?
All right, for the top equation, it's y1 minus y2 minus y1, but in the next one it's y minus y1. So does it matter the order that you put those in as long as you hold them constant?
That's correct. You can choose point 1 and point 2 as any point on the line. And so it even works if you swap the 2. In this example, I'll actually show you it works with both values. Okay? But it's a very good question, and it's one of those things that first time you see it, you kind of think, how can that happen? But it does happen. Okay, so here's another example. It says you try, but I'm going to just walk you through it. You'll do the next one on your own. Okay, so I'm going to find the equation of the line containing 6, 6, and negative 3 and 0. All right, first step, calculate the slope. And so notice my use of parentheses here when I'm taking the differences of the y's and the x's. I do that so I don't mess up on the signs. Okay, I want to take a quantity minus another quantity, a quantity minus another quantity. And so if I just use those parentheses, you can see when I'm putting that 3 in here, okay, I don't have to worry about what's happening to my signs until I start to simplify it. So when I simplify this thing, I get negative 6 over negative 9. The negatives cancel out. 6 over 9 is 2 over 3. Okay, so my slope is 2/3. So then I'm going to choose that 6, 6 as my point that I'm going to put in this equation. Okay, so this is my y value 6, and this is my x value 6. And so I stick it in, this format up here. And then from there, I'm going to simplify it. So I distribute the 2/3 first, and then add 6 to both sides, and I get y equals, 2/3 x. I messed up here. So we'll make this work. This should be an x. How's that? Okay, so we got 2/3 x plus 2. So did you follow the math where I took the 2/3 times x, so I get 2/3 x. 2/3 times -6 is going to be -4. So if we, 2 times 6 is 12, divided by 3 is 4. So we have -4, add 6 to both sides, and we have our equation. Now, to your question about which point do we use, let's use the other point. Now we calculate the same slope, and now I'm going to put in the x value where I had right up here, where x equals -3 and y equals 0. Now notice here, this is a little easier to simplify, really, right? Because you don't need to bring that 0 anywhere, it just disappears, it's just 0. So once you distribute that 2/3 to the -3, you get 2, you get exactly the same equation, which is what you would expect, that, these are any points that are on the line. Okay, so this one I do want you to try, and I'll write on the board the equations just to remind you of them. So I want you to find the line that goes through those 2 points. Okay, so the slope is -3, so and in this case I'm using the first point as y2. Okay, so I have -1 minus 8, that's the difference in the y's. The difference in the x's is 1 minus -2. So I see a -3 or -9 over 3, which turns out to be -3. There's your slope. Then I stick it into the point slope form with that first point. And then what I'm going to do is distribute the -3 to get a +3 at the end there, and then I'm going to subtract 1 from both sides, and I get -3x plus 2. That work? Okay, so let's extend this a little bit with the original definitions that I had with parallel and perpendicular lines to calculate some other lines. So here we have a line that's y equals 5x minus 6, and we want to get it through the point 1, 7. All right, so this one actually goes pretty fast. We're calculating a parallel line from another line. So the first thing that we want to realize is that we already know the slope, right? The slope of this line is 5. And then we're going to stick it into the point slope formula with that one point that we want to go through. So x equals 1, so we have the x minus 1, and then we have y minus 7 because the y value is 7. Yes?
What's the final answer for the last one?
Oh, the last one? Y equals -3x plus 2. Okay? Okay, so here we are. So this is just inserting the point values for x1, y1, and then we simplify it by distributing the 5, adding 7 to both sides, and we get our line. See, there's not very many steps there. I mean, you don't even have to write down the m equals 5. You think that, right? Because it's with a parallel line, you have the same slope, and so you just retain that slope, you put the other point in there, and you'll get the intercept. You see how those equations change, the intercept on the 5x minus 6 is negative 6, and the intercept on the second one is going to be 2, so this new line that we have is going to be above the line of the original line. Now if we want, we can check this. You stick your 1 in for x, and you get 5 times 1 plus 2 is 7. And of course, y equals 7. So the point that you're going through, it works. And then you can check your slope just by inspection. You know your slope is 5. So it meets all the criteria. It goes through this point, and it's parallel to that line. Okay, so now let's look at a perpendicular line. So I want to find the equation to a line that's perpendicular to a line that goes through 2 points. So the 2 points I have are 1, negative 3, and 7, 9, and I want to make sure it goes through the point 2, 3. So all you have to do with this, with the first thing, is calculate the slope. You can certainly find the equation to that first line, but you don't need to. All you need to do is calculate its slope. And so if we calculate the slope, that's the difference in the y's divided by the difference in the x's, and I get a slope of 2. So what do you think the slope of my perpendicular line is going to be? Negative 1/2, right. So then I'll put that as my slope of the second line is negative 1/2, and I stick it into my equation here. So I have my point 2 and 3, so the 2 and 3 go in the right spot. And then simplifying that, I get y equals negative 1/2 x plus 4. Let's see what this looks like graphically. All right, so I'm going to take the 2 points that I originally had and just plot them. So up here is 7, 9, and down here is 1, negative 3. And with 2 lines or 2 points to determine a line, so I can just draw a line through them, and then I'm going to plot my other 2 points. This is a point here. That's the point that I want this line to go through. That's 2, 3. Now, with the equation that I found, you see where the intercept is 4, so I know I'm going to be when x equals 0, y equals 4. So with those two, I can draw a line, and I get the perpendicular line. And so depending on how carefully I drew this, you can see that this is perpendicular to the first line. Okay? So we have 3 different forms of linear equations. The first one we started with is that middle one, the slope-intercept form. That's y equals mx plus b. In the absence of anything else that tells you it's supposed to be in a different form, that's the one that tells you the most about the line, right? Because you can read right off of it directly, the slope is m, the intercept is b. Now this point-slope form is really the form that we're using to get some data points and making an equation out of them. So this point-slope form has this kind of utility to it that allows us to write an equation. Now that top one is standard form, that ax plus by plus c equals 0. Or sometimes you call that the general form. Now, in this form, it's actually, there's some features about it. You don't read the slope off of it directly. You actually have to do some solving to solve for y to get an m out of here. But then as we see as time goes on, this is actually a fairly easy form to graph, because you can graph both your x and your y intercepts pretty directly with that. So we'll leave that to another day, but you'll see the standard form a bit. You just have to manipulate it if you want to read off the slope and the intercept. So this is what I really, really want you to know about linear equations. Okay, so we want given 2 points, we should be able to calculate the slope, should be able to calculate the line. Given a line and a point, we should be able to determine a parallel line through the point and the perpendicular line through that point. So combining that with the first one, if I give you 2 points for a line, you could, and then a third point that it's supposed to go through, just like that last example, you can calculate either parallel or perpendicular lines. And then something we haven't done too much of, but if I show you a graph, you should be able to come up with the equation of the line. So how do you do this? Well, you read off on the graph 2 points that, that you can read off that are simple. You know, one that goes through integer values or so in the best case, or in the worst case, you make an estimate for where these things are going through. Oftentimes reading off the intercepts is a good place to do that, or just when if you see the graph on a grid, see where it goes through an intersection on the grid. And then given an equation, make a graph. Well, this is basically now comes down to two ways to do that. You can take your y equals mx plus b, start at b, your y-intercept, and count off your slope, rise and run, and make your line like that. Or you can just take 2 arbitrary points, let x equals -5 and x equals +5, see where the y's are, plot those 2 points and draw a straight line between them, because any 2 points will determine that line. So pick a point that's easy to calculate, or pick 2 points that are easy to calculate, put them on the graph, and graph it. And then to determine the slope and y-intercept of a linear equation, you read this off directly, y equals mx plus b, or if you have the other 2 forms, form the equation into y equals mx plus b and determine what that is. And then the last thing, I mentioned, I think last Wednesday, about the equation of a vertical and a horizontal line. Okay, so if we look at that, if I have a vertical line, the equation to this is just going to be, let's say this is 6, we're going to have x equals 6. That's a perfectly good equation. For all values of y, x equals 6. Now, when we have a horizontal line, that means your slope is 0, right? Where you have y equals mx plus b, but bm equals 0, and so we just have y equals whatever the intercept is, and if this happens to be a 4, we're going to have y equals 4. So the horizontal and vertical slopes, or the horizontal and vertical equations, let me say that again. The equations to the lines that are horizontal and vertical are actually quite straightforward and simple. You just have to get it, clear in your mind that when you have a vertical line, we're talking about a value of x, because x is one value, y is any value. When we talk about the horizontal line, y is one value, and x is any value. Okay, so those are just 2 special cases of lines. Now, one other thing to note about this is that, remember we said these are perpendicular lines right here, and if we take the negative reciprocal of the slope, we'll get the slope of the other line. So if the slope of the horizontal line is 0, the negative reciprocal is -1 over 0, which isn't a number, right? And so we say that the vertical line has the slope is undefined. I hesitate to say it has no slope, because oftentimes you might construe that to mean the slope is 0. Here, the slope is undefined. It's just straight up and down. Okay, and then before we go off into some examples here, let me talk about another application in linear equations. And so here's an application that we're going to actually calculate the entire equation of the line, and it's something that the problem isn't asking you what the equation of the line is, it's asking you for some facts about the pricing structure of this rental car. So let's say Bill rented a car for, and what I didn't say in here is 1 day. He drove 200 miles and then he paid $95 for it. Katie rented a car, drove 150 miles, and paid $85 for it. The reason why one person gets charged more than the other is because the person who gets charged more drove more. Let me back this up just a little bit. So we have two data points here. We have one that says at 200 miles you pay $95, and at 150 miles you pay $85. So this is the direction you want to go. The X is the independent, the Y is the dependent one. So I tell you the miles, you can tell me the price. Okay, that's the way car rentals work. And so we want to know what the structure of the rate is. So if we look at the 85 minus 95 over 150 minus 200, what we're going to get is the slope of that line. Okay, and the slope is the rate, right? Remember I was talking about the slope as being the rate of change of something. So the rate that you have is dependent on the miles. So for every mile you drive, you're going to pay 20 cents. All right, so that's your rate of change. Now, normally I really like you to use integer ratios, 1/5. When you're asking about money, you don't really say 1/5 of a dollar. I mean, that's specific. It does mean 20 cents. But here I'm going to convert it into 20 cents because that's the form that we traditionally put money in. Okay, so I'm straying from my got to use integer ratios rule on this one a little bit. Okay, so then we put this into our equation here. And we find then we'll use one of the data points, the 95 and 200. And so we get this equation, y equals 0.2x plus 55. And so that means if you've driven 0 miles, you're paying $55. So that's the daily rate, right? So you're going to pay $55 plus whatever mileage you tack onto there. So you can get the rental company rate structure by saying it charges 20 cents a mile plus $55 per day. So the question doesn't ask necessarily make the equation of the line, but by finding the equation of the line, we can answer the question. So, as you're going through, word problems with linear equations, think like this. It's one of those things where, like I said earlier, nobody's ever going to come up to you and ask you to find X. You're going to have to formulate a problem, and you might define X, and then you come back and you answer it independent of X. Here, nobody's going to say, find the line through these 2 points. No, they're going to give you 2 points of data, and they want you to find, essentially, the rate of change and what the intercept is. And that's the code for intercept, the way that translates into ordinary language is when x equals 0, what's the value? In other words, what's the daily value?